Chapter 8. A Man with a Plan. The United States' first year in Panama was discouraging. Millions were spent, but the canal got no further along. In 1905, things began to turn around. The original chief engineer was replaced by John Stevens. Stevens understood how to run a large-scale project. He'd spent his life helping build the great railroads that crossed the North American continent. When he took over the canal project, he was brave enough to put a stop to the digging. He realized there was no point in going ahead until a plan was worked out with all the important questions settled. With the digging on hold, Stevens used the time to deal with the problem of housing and feeding the workers. There wasn't really a good place for them to live. The French had left behind work camps that were airless, damp, and full of bugs and rats. And food had to be bought from local merchants, which was very expensive and often spoiled or moldy. Stevens realized that he needed to attract intelligent, hard workers. The kind of people he wanted wouldn't be willing to stay unless he could offer them a pleasant place to live. So he had the construction crews build dry, comfortable houses for the workers, with baseball diamonds, schools, dance halls, and theaters, so there'd be something to do after hours. The new town along the canal zone wouldn't have looked out of place in New Jersey. Special canal zone stores sold food sent down from the United States for much lower prices than the Panamanian stores. Only Panama Canal workers could shop there. In 1906, Stevens was finally ready to let the digging start again. At last, a definite plan for the canal had been approved. Until now, it had never been completely settled whether the canal would have locks or not. Many people still wanted it built at sea level. Now the U.S. Senate and the President Roosevelt decided, once and for all, they would not try to dig the canal at sea level. They would build a raised canal using locks. When the digging started up again, Stevens did something no one before him had done. He worked out a complete system that would keep construction running at full speed. He understood that the railroad could be used in much better ways than anyone had done so before. The French had sometimes left the dirt they dug out sitting by the side of the canal for days. Not only did it get in the way of the workers, but when it rained, the dirt washed right back into the hole it had been dug from. And when they were ready to haul it away, often no railroad cars were even available. Stevens understood that the entire operation had to work like a watch, with every piece always in the right place at the right time. He bought the best steam shovels available and figured out how much dirt they could dig per hour. Then he rebuilt the railroad so he could run an endless stream of cars to and from the diggers. And as soon as one car was filled, it moved on and another one moved in to take its place. The dirt was taken away to places where it would be needed for construction later. The canal plan that was finally settled on called for building a dam across the river. Before this, the river had been a problem. The new plan turned it into an advantage. The dammed-up waters would form a long artificial lake called Gatun Lake that would become part of the canal. When ships entered the canal from the Atlantic Ocean, a set of 3 locks would lift them up 85 feet above sea level. They'd travel 23 miles across the artificial lake and through a 9-mile-long waterway that today is called the Culebra Cut, that workers would have to blast through the mountain ridge to get to. 3 more locks would lower the ship on the other side. A 3-mile-long breakwater at the Pacific Ocean would help deal with extreme ocean tides. This was an excellent plan, one that had already been proposed by a French engineer 31 years ago, but back then no one had been interested. Theodore Roosevelt was eager to go out and see how his canal was coming along. Every other government figure had traveled to Panama during the dry season, when the weather was pleasant. But Roosevelt went at the height of the rainy season, and he had a wonderful time. He was photographed working one of the giant steam shovels that Stevens had bought. The picture appeared all over the United States and helped make the Panama Canal popular with ordinary citizens. Finally, everything was going well. Chapter 9. Finishing the Job. Then suddenly, in January of 1907, Stevens quit. He never explained why, and no one ever found out. He may simply have been exhausted. He'd done a huge amount of work in just a few years. But Roosevelt was furious. He'd liked Stevens, and now he felt betrayed. So for the last head engineer, the man who would take the canal to completion, he chose a military man, Colonel George Washington Goethals, a soldier Roosevelt believed would never desert his post. Goethals took over a well-run, efficient operation. Wisely, he didn't try to change things that were already working. He concentrated on keeping morale high and making operations simpler. Still, even with everything going smoothly, no one could say that Goethals had an easy job. The men were trying to move more dirt and rock than anyone had ever done before, and to create the largest artificial lake ever in a brutally difficult climate. What's more, once they'd created the lake, it would flood the site of the old railroad, so most of the railroad would have to be rebuilt somewhere else. For Goethals, there were 3 big engineering problems to be conquered. First was the Culebra Cut. For 9 miles, the path of the canal had to be carved 150 feet down through the solid rock of the mountains. Work on the cut went on day and night, with digging during the day and dynamite and cleanup work at night. About 160 trainloads of dirt and rock were removed every day. It was extremely dangerous work. Despite safety precautions, many men were simply blown up. The ground was unstable. Constant blasting made this worse, and sometimes huge slides would fill in a section of the cut. Machines were buried, and days of work were lost. There was nothing to be done about this, however, and Goethals stayed calm. After a very bad slide filled in a section of the cut completely, the engineer in charge came to him in shock, asking what to do. Goethals simply said, "Dig it out again." The landslides have never stopped completely. Even now, sometimes there will be a slide, and a segment of the Culebra Cut will need to be dredged out. The Culebra Cut was the part of the work that most fascinated the world. It became a tourist attraction. As many as 20,000 Americans a year came out to stand on a mountain ridge high above the cut and watch the men at work. After all the discussion, damming the river to create the Gatun Lake turned out to be surprisingly easy. A narrow valley with high hills on both sides proved to be an ideal location. The main problem was that the dam had to be so huge. At its base, it was half a mile wide. It was over 1.25 miles long and 105 feet high. This took a lot of earth to build. But the engineers were removing more than enough material from the Culebra Cut. It was relatively simple to send it by train to the site of the dam and dump it there. As an added benefit, the dam would operate a hydroelectric power plant. This would generate all the electricity needed to run the locks. In October of 1913, President Woodrow Wilson, who was in Washington, D.C., pushed a specially built button thousands of miles away in Panama. This set off a charge of dynamite. The newly created Gatun Lake was joined to the Culebra Cut. Chapter 10. Success. Building the locks was the last challenge before the canal could open. A lot had been learned in the 20 years since the French had first tried to design the locks for Panama. Many of the engineers working there now had helped build and run locks in the Great Lakes. Still, designing the locks was a huge task, because, like the dam, they needed to be so big. At each end of the canal, there were 3 stages of locks, and since the canal would be carrying so much traffic going in both directions, all the locks were made with double chambers, so that more than one ship could travel at a time. This meant 12 chambers needed to be made in all. They were designed to be large enough to hold even the biggest ocean-going ships. Each chamber had to be over 1,000 feet long and 110 feet wide. Nothing so huge had ever been made of concrete before, and a special new way had to be invented to pour the concrete. The locks were operated from a central control room with a miniature model of each canal. Each part of the model moved so that it perfectly matched its position in the actual canal. If the steps for working the locks were done in the wrong order, a terrible accident could happen. If the wrong end of a lock chamber opened first, for instance, a ship might suddenly find itself riding down a waterfall. To prevent this, all the switches were designed so they would open and close only in the right order. Work on the 3 parts of the canal went on for 7 years, under 3 different presidents. Theodore Roosevelt, William Taft, and Woodrow Wilson. At last, on October 10, 1913, a complete, unbroken water pathway from ocean to ocean was completed. In January of the next year, before the canal opened, a construction boat, the Alexandra Lavallee, became the first ship to travel from one end to the other. The first ship to sail through officially was the SS Ancon on August 15th. After spending 10 years and $400 million, the United States had finally succeeded. Huge celebrations had been planned, with fleets of ships coming down to Panama from both sides of the continent. But fate intervened. At the beginning of August, Germany declared war on Russia, France, and Belgium, and World War I began. All the celebrations at Panama were canceled. Still, not even a war could lessen what had been achieved. 401 years after Balboa first crossed the Isthmus of Panama, a dream had been realized. A ship could finally sail straight across the continent from the Atlantic to the Pacific.